So far, we have created two puzzles in our legacy coin journey. One was this legacy CLSP from the last video, and then this other one was password protect from a couple of videos ago. That's awesome. That's all of the Chia Lisp that we're going to need for the legacy coin. And in this video, I'm going to show you how to actually create some coins on the blockchain and then spend them. The first step will be to create this entire puzzle here with Alice's outer coin and then Bob's inner coin and then another inner coin that will be the password protected coin. All right, let's get started. And what I've done here is on my Chia testnet, that GUI that I'm running here, I have three different wallets, okay, and they're going to be represented by Alice, Bob, and we'll call this one Charity. So this is the one that has the password. So I'm going to use all three of these in this video, and just for my convenience, I need to get some info from them all, so it's good if I have it all in one place. So I'm going to create a file called keys.txt. Okay, before I create this file, I need to warn you that what I'm about to do is a very, very bad idea if you're doing this with real money or in real life at all. I'm going to put private keys in a text file, which is a huge, huge no-no. So don't do this at home. And I'm only doing this because A, it's on testnet only. This will never be used on mainnet. And B, I'm going to delete my wallets as soon as I'm done with this video. So there's never going to be any real money here for me to lose. So it's okay for me to expose private keys just for this video. But warning, don't try this at home. Okay, here we go. I'm going to need a wallet address. And I'm going to need a receive puz hash and a public key and a private key from Alice, Bob, and Charity. So let's copy these and paste twice. And Alice and Bob and Charity. So where can I get all of this information from? The best, easiest, I think, way to do it is go to the command line. So if I do chia keys show and wait a couple seconds here, this shows me the information for Alice, for Bob, and for Charity. These correspond to the three wallets that I showed you from the GUI. However, this does not show me the private keys, which I need. And so I need to add one more argument here, which is show mnemonic seed. And that should show me, okay, now I have all of the private information as well as public for all three of these wallets, which will never have real money in them. Okay, first thing that I needed for Alice here was her wallet address, which I can get here. First wallet address is here, and paste that in. Now the receive puz hash is derived from the address, or that might be backwards, but they correspond to each other. And so the way I get the receive puz hash is cdv decode. And we'll put the wallet address in. That is going to be Alice's receive puz hash. So I need that as well, and her public key. I need to make sure these match, so I'm going to use master public key, okay, and her private key is master private key here, okay. And now I'm going to pause this video while I fill in the rest of the data. All right, I'm back and I have filled in all of the keys. So where do we start out with building this puzzle? Let's start with the innermost puzzle here, the red one, the password protected coin. So build that. And the way to start it out is with curry. So cdv clsp curry password protect. I'll pass in the hex file, and that way I don't have to compile it again. And argument. So what arguments do I need for the password protected coin? Just the password hash. So what's the password hash? Oh, well, I don't have one yet. So let's go create one. Run and SHA-256. What did I use before? Chia is good. Let's change this. Let's do a different password. Chia is great. Why not? Okay, that gives me the puzzle hash, or the SHA-256 hash of the word Chia is great for my password. So now I can curry again. cdv clsp curry password protect hex argument will be this. And remember, I'm using 0x for bytes, which was already included. Okay, so that is my password protected puzzle. And I'm going to need to get the tree hash for this puzzle to use later. Tree hash. Now I can build Bob's coin here, which will contain the password protected coin as its inner coin. So let's start that. cdv clsp curry. And this was legacy. We'll use the hex file. Okay, what arguments do I need for the legacy puzzle? I need the owner pub key, the wait time, and the inner puzzle hash. So who owns this coin? It's going to be Bob. And I have that now conveniently laid out here. Bob's pub key is here. Okay, copy that. And remember, always 0x for bytes. Okay, the wait time is how long does Bob have to live? Let's give him a really long lifespan of 1200 seconds. Okay, and then the final argument was the hash of that inner puzzle hash, which I just calculated by doing this tree hash command for the inner puzzle, which was the password protected puzzle. So 0x for bytes, and we pass in the tree hash of the inner puzzle hash. And there we go. So this is Bob's puzzle, and we want to get the tree hash for that to be used in the outer puzzle. And finally, now we can build this outer puzzle, which is Alice's puzzle. She's going to own this coin. So we do again cdv clsp curry legacy puzzle again, and we need Alice's pub key, which I will copy. Okay, 0x for bytes. How long will Alice live? Let's say 600 seconds. And these two values are not cumulative or tied together, the 600 and 1200. I'm just going to say Alice lives for this long and Bob lives for this long. That's all it is. Finally, I need that tree hash that I just figured out with 0x for bytes. Great. Now, this is my puzzle. So we are all set for building it. And I guess next what I want to do is set up some spend bundles to create actual transactions on the blockchain. So how do I do that? And actually, let's do one other thing first. Let's take this puzzle and get a tree hash. Okay, and we're going to convert that into a wallet address. So cdv encode, send in the tree hash there, and we're going to use a prefix of txch. forgot. Usually it's 0x for bytes, but in this case, I do not want 0x for bytes. Okay, so that gives us the tree hash. And if you remember from before, where I excitedly told you that the code really is the coin itself, and the coin is the code, they are tightly intertwined. That's what we're doing here. We're taking all that code, all of this code, and hashing it and creating a wallet address based on the code itself. So this will be the code that we will use for the rest of this this video, and I'm going to copy this wallet address. I'm going to go to Alice, and hopefully she's synced. Yes. I'm going to have Alice send 1,000 mojos to this address. So 1,000 mojos and no fee. Okay, so she is sending that away right now, and I have an outgoing pending transaction. Great. Let's wait for that to finish, or while we're waiting for that to finish, now we can go back and set up these spend bundles for our transactions. Now remember, I had the spend bundle from the password protected coin. Well, let's take that and copy that. So copy spend bundle to spend bundle underscore Alice. So this is going to be Alice's spend bundle. And I can close this old one, grab Alice's spend bundle here, and now I'm just going to delete these values because these were from the password protected coin, which I'm not using now. Except I'll leave this one 1,000 mojos because that's the value that I actually used. Now I already know the puzzle hash because I just calculated it, which was right here. Okay, copy that, paste. What else do I know? I actually know the puzzle too because I just calculated that and I did the tree hash on it, but I haven't gotten the bytes yet. So let's do that right now. Instead of tree hash, do X for bytes. So now I'm taking that code that makes up the puzzle, getting the bytes, and I'll copy that, and that's not going to change because that's the coin itself with all three levels of the coin. So the puzzle reveal will be this. Now the solution I can still change. The parent coin is going to depend on who created this coin. The aggregated signature I'll do in a little bit. But first I want to copy this spend bundle 2 more times. So copy spend bundle Alice to spend bundle Bob, JSON, and Charity. Cool. So now I have 3 spend bundles, each with the first couple of things that are needed already set up, and I can go back and edit those later. So how is Alice going to spend this coin? Let's think about that for a minute. She needs to make up a solution, and she's the owner of the coin. Here, I'll clear the screen. She owns the coin. She can spend it however she wants. The coin already exists on the blockchain. How will she spend it? Let's grab the code here again and just test this out in the command line. So this is the CLSP code of this grand coin with 2 inner coins inside. So I'm going to do run and run this code. Now let's craft a solution for Alice. And if you remember, the legacy puzzle has 3 values for the solution. We need the inner puzzle, inner solution, and spend pub key. Spend pub key we know already. That is Alice's pub key. Okay, copy that. Let's say for now, let's just say the inner puzzle is blank. Blank inner puzzle, blank inner solution, 0x, and spend pub key. Paste that. So what happens here? We get a 50 and a couple of other values. So what was 50? Let's go back to our browser And the conditions, 50 was egg sig me, which had a public key and a message. All right, so those are the two values that it has come up with based on what I sent it, and based on the public key that I sent, and based on the inner puzzle that I sent as well, and everything else that it knows. Okay. You notice something is missing here. Alice didn't actually create any coins, so she's not actually going to send any money to herself or anyone else. So what will happen in Chia, you don't actually burn or destroy money permanently. What happens is we will burn the coin that is out there, which is worth 1,000 mojos, not create any new coins, and therefore the entire value, all 1,000 mojos, will go to the farmer. Okay, so if Alice accidentally did exactly what I've done now, she would lose all her money and it would go straight to the farmer. So you need to be really careful when designing these puzzles to make sure that you're spending them correctly. And again, like I said before, hopefully Alice won't be handcrafting a solution like I'm doing now. She'll be using some other app that will be a higher level layer where it will make sure that she's not going to do something dumb like this. So let's put an actual spend in here. This is her inner puzzle, and her inner puzzle can be anything. Now, she could, if she wanted, go and make a new CLSP file and compile it and do the whole shebang once again. But she doesn't need to do that, actually. All she needs to do to send the money to herself is create some conditions. So what was create coin? That was 51, and we need to do 51, we need a puz hash and an amount. Okay. So what we can do here for our inner puzzle is do a quote and list inside of list. Make sure you get the parentheses correct, because that can be easy to screw up. 51 for create coin. We need Alice's puz hash, or Alice's receive address, right? Let's make sure. Well, yeah, this is where the money is going to go. So I'm calling that receive puz hash, which is here. So it goes to her wallet. And 0x for bytes, paste. Okay, and the amount was 1,000. Let's try that. Okay, now we still have the aggregated signature. She must sign off on this transaction, proving that she's Alice. And she must, or she gets to send all 1,000 mojos to herself. Well, let's say she doesn't want to send it all to herself. Remember, she has total control over this. She is root. Let's say I'll create a second condition here, another 51. Maybe she wants to give half of the money to charity. Okay, what's the charity's receive puz hash? Right here, copy that. And 0x for bytes, paste. And the amount, let's say it's 500 mojos. All right, now we have another aggregated signature, and we have create coin sending it to herself, and another create coin sending it to charity. Now, do you see what the problem is? Yeah, the problem is the original coin was only worth 1,000 mojos, and now I'm creating a coin worth 1,000 and a coin worth 500. So that's not cool. You cannot create money out of thin air in Chia. This is not the US Federal Reserve. You must create exactly the same amount of coins that you are burning if you are creating a solution. So we're only burning 1,000. We can only create 1,000. This should fail. How about this? Let's just test this and see if it actually fails, and then we'll create a better solution that will pass. Okay, so that is going to be Alice's solution. Let's see. Let's get the bytes for that solution. So opc. Actually, we don't need the quotes because they already exist. So remember, I ran the puzzle here, and this was the solution. So I will carefully copy her solution and paste it. That gives me Alice's solution. All right. going back to the spend bundle for Alice, her solution is here. Now, what is the parent coin going to be? Well, for that, we need to look at the blockchain. And let's actually go to the GUI. This coin that I sent a few minutes ago, outgoing, it has been confirmed. So I should be able to see it now if I query the blockchain. So let's do that. CDV RPC coin records and by puzz hash. The puzz hash was this. Okay. And we want one more value, and that's going to be name dict. Okay, the coin exists. It has not been spent yet. That's good. The parent coin was this. Copy that. Oh, and the puzzle hash, it ended with 4AD. So let's make sure that's the same as this. Ends with 4AD. We're good to go. Okay, parent coin. The last thing now we need to do is the aggregated signature. So in order to create that, the easiest way, I think, is by using Python. And I have pulled up this Python file. Yeah, here, signcontribution.python. Oops. Screwed that up. So here's this Python file. This I'm using from the piggy bank tutorial. Thank you very much, Quexington, for making this easy to use. So what you are going to do to create an aggregated signature is you take the private key of whoever is trying to spend the money, and it has to match the public key that we passed in before. And you are using that, and then a concatenation of these three values: data to sign, coin ID, and add data. And I'll explain each of these in detail right now, but let's start with secret key or private key of Alice. Okay, oops. That was right here in keys, Alice's private key. Here we go. Copy that, put it into the signature. And so in theory, only Alice will have her private key. Nobody else should have access to it. So this is how she can prove her identity. Okay, what was the data to sign? Well, that was this message from the web browser here. AgSigmy has this message here. So that was the second value of 50 AgSigmy. So let's go back to the command line. And remember, when I created the puzzle, I used the tree hash of the inner puzzle for my message, and that way no one can go and change the inner puzzle later and try to spend the money themselves. So when I created Alice's solution up here, I created, it spat out a 50, where'd that go? 50 for signature. Here's her public key, and this is that message. So let's copy this minus the 0x. That is the puzzle hash of the inner puzzle. Okay, copy that and go back to here and paste. Okay, coin ID I just got, and that was over here. When I did name dict, the first value to come up is the coin ID. Copy that. Paste. Now, the final thing, I need to take a couple minutes to talk about additional data, because this is important, and depending on when you watch this video, it could change. So I'm recording this in October 2021, and as of right now, there is a bug in the testnet. And the bug is that every single transaction that is going through that is being signed incorrectly. This additional data is supposed to be the genesis challenge of whatever network you are on. And in terms of testnet 7, that should be this value here that's commented out. However, because of this bug, I need to use this value, which is mainnet's genesis challenge, in order to craft this aggregated signature. Now, is this a big deal as far as how big of a bug this is? Well, I don't think it really matters, although I'm far from an expert in this, because while this was created to prevent replay attacks, where basically if you have the Genesis challenge integrated within the signature, someone can't look at the testnet and see a signature and then see the exact same signature pop up on the mainnet and know how to use it and try to reuse the signature and then steal someone's money. Okay, that's a form of a replay attack. This is supposed to prevent that. Now, it might still be really hard to do a replay attack because we still are using the coin ID, which is based on the parent coin, and so I would think that would change with every single signature. But like I said, I'm not an expert in this, and I think probably what's best to do for now is avoid using the same signature on both testnet and mainnet until this bug gets resolved. And how do you know if this bug has been resolved? They're definitely going to fix it at some point. I don't know how. You should ask the Chia folks if they've figured out what they're going to do yet. It could either be fix testnet 7 or it could be create a new testnet. So if you go onto your GUI and you see a testnet higher than 7, let's see, right now we are on 7. If this is higher than 7, it's very likely that this has been fixed. If it still is 7, well, it actually might be fixed as well. They might have figured out a way to do it without creating a new testnet. I just don't know. You're going to have to play with the signature and maybe swap out these values, especially if you get a bad aggregate signature when you attempt to make a spend. This might be the reason why. So for now, I'm going to assume that the bug is still there. I'm going to use mainnet's Genesis, which is this one, and craft my aggregated signature from that. Okay, so how do I build this? All I need to do is run Python 3, and sign contribution pi. That spits out an aggregated signature. I can then copy it and go back to my spend bundle, paste. Okay, so that should be everything I need for Alice to be able to spend this money. So let's go and test it out first of all. So cdv inspect spend bundles and spend bundle Alice and -db for debug. Great, so aggregated signature has passed, again, using the incorrect additional data, but that's what I need. But it has not detected this problem here, this 1,500 coins being created and only 1,000 being spent. So you can think of this this inspect spend bundles command not as actually being smart enough to go through all of the coins that are actually on the blockchain. This is more just checking that your syntax is correct. So I'm ready to try to push this invalid signature onto the network. Let's see what happens. cdev rpc push tx and spend bundle Alice. Okay, I get a failure, and the error is minting coin, which I guess means you're spending more than you are burning, which is not allowed. Okay, that's exactly what I wanted. Now let's fix this and try to spend the coin for real. Let's go back up to this solution, and actually I'm going to go, because I need to change one other thing, I'm going to go to run the whole command and change 1,000 to 500. So she'll send, Alice is going to send 1,000 mojos to herself or I'm sorry, 500 to herself and 500 to Charity, and using her key. Okay, cool. Now, I can do one more little test first before I move on. Let's say instead of using Alice's key, let's say I used Bob's public key, right? And did this exact same transaction. What would happen here? So I remove Alice's public key, swap it out for Bob's. Okay, now I get an exception. Inner puzzle does not match hash. That's exactly what I wanted, because now only Alice gets to spend the money however she wants. Bob has to craft that inner puzzle exactly how it was originally crafted. And that is where we did this verify inner in the legacy GLisp, and we're getting this error right here, which is good. Okay, back up to Alice. It works. Now do opc to get her new solution, which creates the correct number of mojos. Paste. Okay, that's her solution. And I'll copy that. Go back to her spend bundle. Delete this, paste. Oh, that I did wrong. Okay, that was the aggregated signature, which I do need to recalculate anyway. And her solution was here, paste. All right, now let's redo her signature. What changed? Well, her key stayed the same. The coin is the same, and this is the same. The only thing that changed is this data assign, because the inner puzzle has changed. So now the hash of the inner puzzle will have changed. So I need to go back up and look at 50 and grab that second value, hash of inner puzzle here, and paste. Okay. Now run Python 3 and run sign contribution to get a new signature, copy, and back to the spend bundle and paste. Okay, now we should be all set. Let's inspect it. CDV, inspect, spend bundles with an S, and spend bundle, Alice, debug. Okay, I've done something wrong here. Okay, sorry about that. I think all I did wrong was I forgot the hyphen here for DB. Yeah, that was the only problem. Okay. This time, 1,000 mojos are being burned, and a total of 1,000 are being created. The aggregated signature still passes. That's good. Let's see if I can actually spend this coin. CDV, RPC, push TX. Spend bundle, Alice. And success. Great. So now if I go back to the GUI and to my wallet, Alice and the charity should each receive 500 mojos. Let's go over to the charity. Okay. So far, 0 mojos here. I need to sync this, then I should receive the money. So I'm going to pause the video right now and come back. Okay, this is good news. I'm still on the charity's wallet, and 500 mojos has come in. Cool. And that happened just a few minutes ago. Now let's go back to Alice's wallet, and the other 500 mojos should have gone there. Of course, it might not be synced anymore. Come on. We'll give that a second here. Okay, it's not quite synced up yet. Let's go back to the command line and see if this has been spent. So remember that was the coin records command, and spent is now true, and so that money is gone. Great. And it's been split up, 500 mojos to Alice, 500 mojos to charity. Incoming, good. We have incoming 500 mojos. So that has gone through successfully. Let's create another one of those coins and test Bob spending it. See what happens then. So I'm going to go to this outgoing coin where I sent 1,000 mojos. I'll send another 1,000 to the exact same spot because I'm not changing the puzzle itself. Oh, I need to do mojos, not 1 quadrillion mojos. That's too many. Just 1,000. Okay, there we go. And 0 fee. It's gone through. So how can Bob spend this money? If we go back to where I did the command here, and remember I swapped Bob's receipt or Bob's public key here for Alice. So this is where Bob was trying to spend it, and I get that inner puzzle does not match. What I need to do is I cannot use this inner puzzle. I must use the exact same inner puzzle that I had before. So what did that puzzle look like? Let's see, we need the curry command that I used for Bob way back when, and that was right here. So this is the curry command with tree hash. I don't need that one now. I need to get that inner puzzle. That's right here. This is the original inner puzzle for Bob. That would be, just to make this super clear, that would be this blue puzzle here. So when I go to spend the coin, if I'm Bob, I need to, first of all, get rid of this and get rid of this. Make sure I don't delete too many parentheses. This will be an empty puzzle. Now I can fill in that inner puzzle that I just got instead of the empty puzzle. And what was the inner solution then? Well, the inner solution is going to be the solution to Bob's puzzle, which itself required an inner puzzle, an inner solution, and a spend pub key. So let's go back, and inside the inner solution we create, let's just do blank for now, a blank inner puzzle, blank inner solution, Bob's spend pub key, which was, go back and get that here, and so this is Bob's, sorry, Bob's not spend pub key, but Bob's just pub key, copy, and I will, 0x for bytes, I will paste. Okay, now you'll notice I have Bob's pub key written down twice. Technically, I don't need this exact same pub key twice. I only need it for the inner puzzle, and I could use anything other than Alice for the outer puzzle. But just to avoid even more confusion, I'm just going to use it twice. I think it's slightly easier to read. All right, now I get 8,600. So 80, if you remember, was the condition for right here, assert seconds relative. So I need to wait that many seconds after the coin has been created before I can spend it. And then it's the same thing. I'm doing a aggregated signature. I'm not creating the coin, so I need to be very careful once again to create the coin for Bob. And this time, let's just send all 1,000 mojos to Bob. So his inner puzzle is going to be, let's see, quote. Okay, get the number of parentheses correct, and he's going to do 51 to send a coin to himself, and his receive puzzle hash, where the money goes, is going to be here. And that I need a 0x for bytes, paste, and 1,000. Okay. And this time I once again get 8,600. Good. I get the signature required, and this time I have a create coin, 1,000 mojos. Okay, that was exactly what I wanted. So let's run op-c on that solution to get the bytes for it. And this solution is going to be quite long. It starts with the quote here. It contains the entire inner puzzle, so that's why it's so long. So there we go. It's all of this. Okay, and I will copy. All right, that needs to go over to Bob's spend bundle. That's his solution. Now let's work on that sign contribution. So I'll delete this, and let's delete that too. Okay, Bob's private key was right here, and that will get pasted. Private key. Now, what data did Bob sign? That was that aggregated signature data that got spat out in this list of conditions, and it's the second one, which is right here. Cool. Same thing with Alice, just now with Bob. And the coin ID, okay, we still need to get that from the blockchain. So let's go back. Remember, I just created that coin. Hopefully it's out there by now. CDV, RPC, coin records by puzz hash. Same puzz hash as always. It's going to be this one. Okay, and there. All right, now we have 2 coins. So this is the other one that I already created and spent. Spent is true. This one, spent, is false. Oh, and I need to do name dict to get the coin ID. So let's go to spent false. First, let's copy the parent coin here. Copy. And come on. Paste in the parent coin, and I still need that signature. And to get the signature, I need the ID. Great. The ID of the unspent coin was right here. Copy and go back here, and let's try to paste. Okay, that should be everything I need to create the aggregated signature. Python 3 sign contribution. That's my signature. Awesome. I can put that into the spend bundle for Bob. And now we're good to go. So let's test that out. CDV inspect spend bundles and spend bundle Bob this time and debug. All right. Ooh, it's a little slow. Come on. We are spending 1,000 mojos. We're creating 1,000 mojos. That's good. And we should also be asserting seconds relative 600. Now, depending on how long I have taken in order to do this, everything else looks good, by the way. The signature looks fine. Depending on how long it's been, this may or may not work. So CDV RPC push TX. We're actually going to push it out. Spend bundle Bob. See if that works. And no, it does not work. And that is really good because the failure is assert seconds relative failed. We have not waited for Alice to die. So Bob has all of the info he needs right now while Alice is still alive and well. Alice has given him this info and he can put it in his pocket and go on his merry way. And whenever she dies, then he can be ready to spend the money using the info that he already has. But we have not waited long enough. So how long have we waited and how much longer do we have to go? It depends on the blockchain. Sometimes this can be a little slow. So I'm going to pause here. And actually I'm going to go here and pause and come back in a few minutes and see if I can spend the money then. It has to be 10 minutes, not since I created the coin using the GUI, but 10 minutes since the transaction actually cleared. And that's going to be important because sometimes it takes a couple minutes for it to clear. Okay, be right back. Okay, it's been a few minutes. Let's see if the exact same transaction that I just did that previously failed, let's see if it works now. Yes, success is true. This means that Alice has died and now Bob can spend the money. And if I go back up to Bob's wallet in a few minutes, I should see that money show up. So let's do one more test before I let you go to see what happens if the charity or really anyone else tries to spend the money other than Alice or Bob. Okay, I have sent this money off twice already or sent coins off to this address twice. I will use the same thing one more time. So anytime Alice wants to create this legacy coin, once she gets it all set up, like I've done in this video, she can just keep using the exact same address. She just has to send money to that address and it will be locked up in exactly the same way each time. Okay, let's do, again, 1,000 mojos, and 0 fee. Okay, so Alice sends that money off. It is now locked up once again. Let's look at that last transaction. Go to Bob's wallet, and come on. Sometimes it takes a few clicks. Slightly buggy gooey at times. And loading up Bob's wallet now. Okay, and did the money come in yet? No, it has not. Okay, well, let's give that a few more minutes for that transaction to get finalized on the blockchain, because I really did just push it through. And meanwhile, we're going to look at set up a solution for the charity. So let's go back up and look at Bob's solution. Remember, oh, that was just the solution, the opc command. This is the command Bob used to generate his solution and puzzle. Okay. Let's grab the charity's public key first of all. Let's see, public key for charity is here. Back to the command line. And I'm going to swap out Bob's key for the charities. Let's see, leaving in 0x. And I'll do that both times, paste and then paste again. So this is the charity attempting to spend the money in the same way. Oh, it's going to be sending it to Bob's wallet, but fine. Let's say the charity wants to do that. Does not work, again, because I've now made it into, if we go back here, I've made it into Bob's coin, and I'm not Bob anymore. So because I'm not Alice and I'm not Bob, I'm somebody else, I need to show the actual inner puzzle in order to spend the coin, which is exactly the behavior that I wanted. So first I need to grab the actual puzzle for this coin, which I created quite a while ago. I could redo it, but I'll just up arrow until I get to it. And I should be able to see it. Let's see. Right here, password protect, and that was my password. That was to get the tree hash. Now I just want the CLVM code, which is right here. Okay, let's push that up a little bit, and I've already got the charity's public key here. This could get a little confusing if it's not already. Let's delete this 51. Make sure I delete that set of parentheses and that set of parentheses and that quote. So now for now I have just a blank inner puzzle, but I don't want that. I actually want this inner puzzle, and I have to reveal that in order to spend the coin if I'm the charity or anyone other than Alice and Bob. Okay, paste that in. The solution. Now I need the solution for the password protected coin. So what was that? Again, let's go back here. We need the password, the receive puzzle hash, and the amount. So receive puzzle hash, charity will just send the money to itself. Let's see that, copy that puzzle hash. The password, what was the password again? Chia, is great. Let's do a wrong password just to test it out. Chia is good. And send it 0x, send the money to the charity, and let's just keep the amount at 1,000. Okay, and I get bad password. Okay, that's exactly what I wanted. Now I'm going to scroll all the way back to the password and change it to Chia is great. Right here. Okay. Okay, now I get a new set of conditions, and you'll notice there's no aggregated signature this time. I just have to wait. This simulates Alice dying. I also have to wait for Bob to die. And then, as long as I have that password, I can spend this money. And so now the legacy puzzle is relying on whatever's inside of it to do the security beyond this point, beyond waiting for these two people to die. The legacy puzzle doesn't particularly care how secure or insecure the inner coin is. And in this case, it's not very secure, so I would not recommend doing this exactly like this in real life. Your very inside coin would probably require an aggregated signature or some sort of verification of identity beyond just the password, as I've explained previously. But this is just a test, and so all it's going to do is create the coin. This looks like a good solution to me. So let's get the bytes for the solution. Opc. I don't need the quotes. I need to go back to the beginning of the solution, which is way up here, and copy the whole thing. Okay. And that will give me the bytes for the solution, which gets bigger and bigger as we go inside further. Copy. Back up to here, and the charity spend bundle. Let's fill that in. Solution. Okay, let's go back while we're at it to the GUI. And remember, this was Bob's wallet right here, the second one. And Bob has received 1,000 mojos. So that's really good news. That spend actually worked. Bob spent the previous coin after Alice had died. He had to wait, which is what we wanted. Now we've pushed out another coin. So let's take a look at the coin records once again. CDV RPC coin records. And by puzz hash, we're going to get the exact same puzz hash as before, which is here. And I should see 3 coins now. Let's see. Oh, I only see 2 so far. So I guess that means the third one hasn't been pushed out yet. But I do get spent true and spent true. So let's just go back to Alice right here. And she should have pushed out that third coin. Either I did something wrong or it's still pending. So let's check that out and see what's going on. It says pending, and I'm waiting for it to sync once again. I'm going to pause it right here, wait for this thing to sync, and wait until this gets complete. Sometimes the test net is a little bit slow to confirm transactions. It's not really a problem on mainnet, but I don't know exactly why this is happening, but there it is. So pausing right here, coming back soon. Okay, I'm back, and that didn't actually take too much longer, so the transaction has been confirmed. Now if I go back and run the same coin records command, I should get 3 coins. Good. This one has been spent. This one has not been spent, and this one has been spent. So they don't exactly go in order always. That's interesting. So always make sure you get the right coin. And I forgot to do name dict. So let's do, oh, actually I don't even need name dict because I don't need a signature. So I don't need the coin ID. I only need, in this case, spent false. I need the parent coin, which I will copy. Okay, parent coin is here. So I already have my puzzle and my solution. Aggregated signature, like I said, it doesn't require an aggregated signature. So what I'm gonna do is go back to that spend bundle that I used before and just copy the default aggregated signature, which is all those zeros, and paste that in. And now I should be able to spend this money. Let's see what happens. CDV inspect spend bundles and the charity and debug. Okay. The signature check passed, and there's no data being sent in. I'm just using the default. This all looks very good. The conditions that I need are assert seconds relative. So waiting for Alice to die, 600 seconds, waiting for Bob to die, 1200 seconds. And then I get to create this coin and send it to the charity, as long as that password is correct, and I've already verified that that's correct. So this will still likely fail if I try to do push TX. So let's see if it fails because I have not waited 1200 seconds. So CDV RPC push TX and spend bundle charity. Okay, still fails. Assert seconds relative failed. That's exactly the behavior that I wanted. So now I'm going to pause the video again and wait 20 minutes for this to go for those conditions to be met for Alice and Bob to both be dead in this simulation. And I'll be right back. Okay, I'm back and I have waited several minutes. Hopefully I've given it a sufficient amount of time for this transaction to go through. Remember, I have to wait 1200 seconds here for Bob to die before the charity can spend the money. Let's see, has it been long enough? I'm going to try the exact same transaction, same spend bundle, and yes, it works. Okay, so the money has been spent, has been sent to the charity, and if I go back to here, this is the charity's wallet. I'll pull that up again. And I should see 1,000 mojos pop up in this wallet pretty soon. I've already got 500 from previously in this video that Alice sent to the charity. And that's the last of the test cases that I'm going to show you today. Obviously, you could make all kinds of different tests out of this and create a whole testing framework based on it. But you can see how powerful this is and the different spots that you can go with this type of coin. Remember, the original puzzle was only like 50 lines of code, yet it's able to do so much. We showed you how Alice and Bob and the charity all have different requirements for what they enter into the solution, yet they can predict what their solution will be ahead of time. So both Bob and the charity were holding on to those spend bundles when it was failing, and they simply had to wait for Alice, or for both Alice and Bob, to die before it would work. So this could be a really nice thing to have, where the charity has all of the information it needs to spend the money, and Alice and Bob can give them that money or that information while they're still alive and potentially wipe out middlemen. Oh, and look at this. The extra 1,000 mojos has now come through. Great. So that's all I'm going to show you for this tutorial. I hope you've gotten a lot out of it. Feel free to play around with this puzzle that all the code that I'm putting out on my GitHub to change it as you like. It's all out there for anyone to use. And if you have any questions, Keybase is definitely the best spot to go. Okay, thanks everyone for watching. Take care.